Lucy mission, and the Psyche mission. So Perseverance just landed on Thursday. It will be on Mars for one Mars year, which is about 2 Earth years. And it is the first mission to look for signs of ancient life, ancient microbial life. I think of them as ancient fossils. And to look at the geology and climate of Mars, and it's going to help pave the way for humans. I don't think I'm old enough when people actually go to Mars to go, but some of you should be if that's what interests you. It has one of the instruments, MOXIE, is going to look on making oxygen on Mars, and it's also studying the climate to see what that's like. And it's collecting samples, because to analyze the samples for ancient microbial life, they really need to bring them back to Earth. So this will be the first trip where it collects samples of a round trip of those samples to return to Earth. And the first video I have is a short Perseverance overview video. So hopefully it runs and we'll start that up.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration of Mars.
Okay, so the mission goals are to study the geology and climate, to see where it might have been capable of supporting life once. We'll look for signs of possible past microbial life in those places. it will gather some samples of rock. The mission is capable of gathering 42 samples. Some of them are going to be test samples, so perhaps 40 usable samples. So it's got to pick those places. It used to be when I was in high school that there was a clear soil had to have organic material. So we differentiated between regolith on the moon or Mars and soil, which was earth-based and had organic material. But now geologists say that soil can be used to classify the lunar or Martian rocks. So you actually can say soil, which you couldn't like 2 years ago. And it will prepare for humans. It's going to have that helicopter ingenuity to see if it would fly. And like I mentioned, one of the experiments is called MOXIE, which will try to make oxygen out of the thin carbon dioxide atmosphere of Mars, both for people to breathe and for rocket fuel, because it's impractical to blast something off of Mars and bring that oxygen all the way from Earth. So it really is important and a lot cheaper if we can make oxygen on Mars itself. The atmosphere on Mars is 1/100th that of Earth, and it's mostly carbon dioxide. So it's a thin, very thin carbon dioxide atmosphere. And they believe that MOXIE can make oxygen, but tests are one thing and actually trying it on Mars is another. And this was a picture captured as Perseverance landed on Thursday. That's the European orbiter, the Mars Reconnaissance Orbiter, capturing Perseverance and its parachute from orbit, which is I think really cool as it lands. And I don't have the 5-minute landing video from Thursday. I figured y'all could watch it if you haven't already. I should mention that the mission is Mars 2020. The rover is Perseverance. Some people have been calling the Perseverance rover Percy. I hear that sometimes too, and I might do that. But the mission and the rover are two distinct things. And here is one of the cameras from the sky crane as Perseverance is lowered onto the surface of Mars. Perseverance in the Mars 2020 mission has 29 cameras, and this is from the sky crane looking down. You can see the 6 wheels, and notice there are the tethers, and then one is kind of thicker. That's the umbilical, and that is information from the sky crane to the rover and from the rover to the sky crane. They mentioned that they used Linux for a lot of the coding. Now, I don't use Linux, but my husband does. He's got a Linux computer, and perhaps some of you already know Linux or easily can learn Linux, and that's something that is amazing. They go all the way to Mars on Linux. EDL, which stands for Entry, Descent, and Landing. That's what they did last Thursday, and it is the most dangerous, critical part of the mission. And hundreds of things had to happen, all in the correct sequence. The whole thing is called 7 Minutes of Terror. And there's the Curiosity 7 Minutes of Terror video, which you can also watch, because the chassis was the same as Curiosity and it landed in the same way. The mission hits the atmosphere, the Martian atmosphere, going over 12,000 miles per hour and heats up. It's got a heat shield. and uses its thruster. It's like a meteor shooting through across the sky of Mars. And then it deploys the supersonic parachute, the 70 feet in diameter. And it's supersonic because it's still traveling 2 times the speed of sound. It jettisons the heat shield when it finally is cool enough so it can figure out where to land. It's like a big lens cover. So the mission was aiming and needed to see if there was a safe place to land. When the parachute is done, it's still going 150 miles per hour, which is too fast for it to land. It's as fast as a skydiver on Earth with no parachute. And it fires up its engines, it slows down to 1.5 miles, and then it uses the sky crane, which gently lowers it to slower than walking speed. And it had to do this with no Earth help. Mars is about 7 light minutes signal from Earth. So by the time it lands, it's already landed or crashed. There's no way that it could communicate with us in real time. And here is this parachute. I wondered about why the parachute had those markings like it did. It apparently says in binary, "Dear Mighty Things," which is one of the slogans of JPL. So that's why it was colored kind of red and white. JPL said that it was for calibration purposes. Of course, Curiosity, if you saw the Curiosity wheels, they also spelled as it roved JPL in like Morse code, which they said was for calibration purposes too, because the wheels sometimes slipped. So they have these little Easter eggs, and one of them is Dear Mighty Things, and the outer ring is the Earth coordinates, longitude and latitude for JPL in Pasadena, California. So, and here is the landing video. I'm not gonna run it. It's about 3.5 minutes long. It was all successful and people were applauding, as they should. Now for where it's landing on Mars, and to the left it shows where Jezero crater is in comparison with Mars. It's part of this big acidus basin, and Jezero crater is this little thing right here. Hopefully you can see my pointer. That's Jezero crater. The whole thing is an impact crater that once slammed in almost 4 billion years ago. But Acidus Basin was very interesting to them, and Jezero crater, this little thing, because here is a picture from orbit again from the European orbiter, because this right here, the whole thing is Jezero crater. That little thing on the previous slide, that little thing is this whole thing right there. And that's the landing ellipse right next to that delta. They think that this was an ancient lake, and it shows an inlet channel right here and an outlet channel right there. So they're thinking it was filled with flowing water long ago. And deltas on Earth are a good place of life, teeming with life. So they thought that this would not only be a place where life existed, but it should preserve evidence thereof. And here is kind of a side view to show the elevations. And they always say that Jezero crater is about the size of Lake Tahoe. I have no idea the size of Lake Tahoe. I know that it's about 30 miles across. There's no water on Mars today. Today, Mars is too cold for water. It's too dry for water. There's no liquid water on the surface of Mars. There might be water underneath. There's certainly fog. There's certainly a few clouds. There's ice on Mars, but no liquid water. And the lake that existed in Jezero was long gone. And I don't know why I have this slide. This is from Alaska, and it just shows a river delta in Alaska, the way that it would look, that Jezero crater hopefully looked like billions of years ago, teeming with microbial life. This particular chart I really love. And what it shows is it shows time from the left to the right and the time that things happened. So about 4.7 billion years ago, the sun ignited and Earth formed and the moon formed. And Mars was very much like Earth once, smaller. It had water on its surface though, and it had a turn off. It became unlike Earth. The climate changed about 3.3 billion years ago. You can see from the big yellow arrow here. And you can see that it is after this misspelled photosynthesis. So there was life on Earth, and Mars was life like Earth billions of years ago. And they think that Mars could have had microbial life. Over time, there's the more recognizable fossils. The dinosaurs were 65 million years ago is when they died off. But the type of life that they're looking for is microbial, certainly after photosynthesis. And it's possible there could be life. That's what Perseverance is looking to find. They think that Mars was once habitable, but habitable does not mean inhabited. Now, if Mars is inhabited, that would be really cool. If Mars is not inhabited and Perseverance can find no sign of life, that's also a scientific result. It would mean that life is less common than some scientists think. So that's also an important find. This is a cut stromatolite. You can see it's just a few millimeters. We have one at the museum that we just got. Stromatolites are found, fossilized stromatolites are found worldwide along ancient shores. The one that we have is from Western Virginia. And stromatolite means layered rock. It is a fossil. What happens is, and I've got the next slide, I think, is modern stromatolites. This is from Western Australia. Those rocky looking things are living microbe colonies. Stromatolites are, the living stromatolites are on the surface. The blue-green algae forms microbial mats along the surface. They change carbon dioxide to oxygen, and much like corals, you know, the living polyps are on the very surface, and then they build the bones underneath. That's what stromatolites do. And it's stromatolites that Perseverance will be looking for on Mars, evidence of fossilized life. We go back to this one. The very top has the more recent fossils. And the layers, each one is a little bit older. So it's like a little time capsule. Each layer underneath is a little bit older. They look humpy, bumpy. You wouldn't look at that and think of it as a fossil. I know, I certainly didn't. I just thought of it as rock. But that is what Perseverance will collect, samples that look like this, because they hope, they don't know, but they hope there will be fossilized stromatolites on Earth. Now, stromatolites formed about, the first ones formed about 3.5 billion years ago, and they dominated life on Earth for the first 2 billion years or so, if we go back to here. The first 2 billion years or so, stromatolites dominated life on Earth. And because they were so prevalent and they used photosynthesis to make oxygen from carbon dioxide, we think that long ago they helped make the oxygen atmosphere that we have on Earth. And they caused some of the die-off of ancient forms of life billions of years ago. So that they changed, stromatolites changed the climate on Earth, but they certainly formed before that climate change happened. And now for the instruments. Although the chassis is very much the same as the chassis of Curiosity, the instrument suite is all new. There's more instruments and they are better. I have one of those Hot Wheels. I don't know if you bought a Perseverance Hot Wheel toy. They sell them at Target and Walmart and things like that. They're less than $2. When Mattel made them, they used the Curiosity template. So they're identical to Curiosity, except they're labeled Perseverance. One of the ways you can tell the difference on the real rovers, when you see the footage, is that the wheels are different. The Curiosity wheels didn't do so well. They tore up and slipped. And so the Curiosity wheels have kind of a wavy pattern, and the Perseverance wheels have a horizontal pattern. But the Hot Wheels toy, you can't see either of those on the wheels. So they were able to use and just relabel what they had, which means, I guess, if you have a Curiosity Hot Wheel, you could kind of use the same. Perseverance is going to drill and prepare samples. It's got this arm that will drill samples. And once it collects them, it will cache them for ultimate retrieval back to Earth, which another orbiter will do. The Fetch rover will collect the samples and launch them on a rocket. We still don't know how to do that yet because we don't know if we can make oxygen on Mars. And then a third rover or a third orbiter will capture the samples from that rocket for safe delivery to Earth. It probably will be 2031, in 10 years, before we see these samples on Earth. And those samples can be studied by people worldwide. They can petition. So think about where you'll be in 10 years, where you hope you'll be in 10 years, and you could be studying the samples of Mars and seeing if life existed for the first time elsewhere in the solar system. That's why I'm so excited to speak to high schoolers, because if that's what you want to do, certainly it is possible for you. You could be one of the next people on the moon. You could be the first person on Mars, but you also could be one of the people who studies and looks for life on another planet. And next we have another video. It's the sample caching video, which kind of explains what the arm does. And we're going to start that.
terms of robots that go into space, the sampling and caching system on the Mars 2020 mission is the most complicated, most sophisticated thing that we know how to build. This is a system that allows us to take core samples of rocky material on the surface of Mars, carefully seal them in very sterile, clean vessels for eventual return to Earth. We've been working on the sampling and caching system for 7 years, and that's because it's a tough job.
We're testing the equipment to make sure that it's going to work when we get to Mars. It has to function on its own. We have to think of all eventual possibilities and try them here first. And then if they don't work, change it now because we can't make any changes later.
To drill into the rock on Mars, pull out intact core samples, seal them hermetically, and to be all done autonomously by a robot hanging off the end of a rover on the surface of Mars has been a challenge. We've got actually 3 robots necessary to do the sample and caching system. Our big robotic arm out on the front of the rover, that takes our drill, pushes it against the surface, and allows us to take core samples. Then we put that core sample in the bit carousel, the second robot that takes that from the robot arm and puts it down inside our adaptive caching system. This is the part of the sample and caching system inside the rover. We've got a little tiny robot, a special robot arm called the SHAW, the sample handling arm. It takes the samples out of the carousel and moves them through volume assessment, image taking, and eventually to sealing, and then replaces the cylinder containing the sample in a storage spot, all on its own in the matter of a few hours. We have designs on bringing them back in a decade. Mars has been at the fore of our consciousness about the questions of life. Could life exist in one of our nearest neighbors? I think we have a lot to learn, life or no life, about the evolution of our solar system, about our planet, by looking in depth at rocks brought back from Mars.
Okay, and next is just kind of a listing of the instruments. I'll just talk very briefly about each one. I just couldn't not talk about any of them. Mastcam Z is where they're going to get the color pictures, the 350, the 360, the 3D images. There's 2 cameras, and it can look a football field away and still get up close pictures. So it's zoomable and 3D. Supercam is a camera that has a laser. So what it's going to do is it's going to pulverize rock and then take a picture of the resulting smoke or the resulting pulverization and look up close with the laser what the rock is made up of. Pixel is on the robot arm, and it is going to look at the rock closely on a very fine scale. And also on the robot arm are Sherlock and Watson. Sherlock is going to look for carbon and organic molecules and minerals, and Watson is the camera associated with it. So where there's Sherlock, there's Watson. RIMFAX is going to, for the first time, look underneath Mars to see if there is a reservoir of water. InSight had that little mole, which some kind of worked, kind of didn't. But this is going to look more closely to see if there's water underneath. Meta, all of the Mars rovers have weather stations because they want to prepare for people. They want to know what the temperature is like, what the wind is like, that sort of thing. So Meta is what they're using for Percy. MOXIE is a proof of concept. MOXIE, once again, is going to try to make oxygen out of the thin Martian carbon dioxide atmosphere, both for fuel to return and for humans to breathe. And that is pretty much all of the instruments. They're also exciting. And this was taken on Thursday, one of Perseverance's wheels. So you can see it's got the horizontal treads, and it is not Curiosity, because Curiosity has the zigzags. So this was taken by one of the hazard cameras, which will help to decide where the rover is going to go. And then Ingenuity, I certainly can't talk about Ingenuity. Ingenuity was named by a high schooler. She came up with the name and wrote an essay. It's a small helicopter. It's only about 4 pounds. I remember now why I showed this. It's right in the belly of Perseverance. Perseverance is going to drop it and then drive away. So it's stowed, and it will be used about 1 month into the mission. Early in the mission, it's going to make 90-second test flights, no more than 6 stories high, just to see if a helicopter can indeed fly on another planet. They think it will. They've tested it in a test chamber. To be able to fly in the thin Martian atmosphere, it has to be lightweight, long double rotor, and it needs to go about 3 times faster than Earth helicopters. So fast, and really excited about it. And then you can follow.
I have a
You
real
can
question.
follow Perseverance as it travels. Here's the website. Hopefully, if this is recorded, you can just look it up, or where's the rover. This I took yesterday evening. It shows where the rover is and the landing ellipse. And this whole thing is Jezero crater. They're calling the inflow channel something here from the ancient lake. And wanted to mention a little bit about Lucy and Psyche. I know I don't have a lot of time. Lucy is going to launch later this year. It is going to look for it's going to look closely at Trojan asteroids. I'm going to stop this. I think I can stop it. Probably not. It's still annoying. The Trojan asteroids are asteroids that share the orbit with Jupiter here. This is L4, and this one is L5. That's stable. At the Lagrange points, it's stable. They share an orbit with Jupiter. They're not in the main asteroid belt. We think that they are left over from the early solar system formation, and we have never really seen one. It launches in 2021. It's going to look at a main belt asteroid, that's MBA, main belt asteroid, Donald Johanson, in 2025. And Lucy is named for a primitive hominid, early human, not a Homo sapien, but a early human fossil. And it was discovered, Lucy was discovered by a man named Donald Johanson. So it makes sense that that's the asteroid that we would visit. It is going to see 7 asteroids in total. The other 6 will be Trojan asteroids, and it will fly by the first one in 2027. And it's using solar electric propulsion. And Psyche is really one of my favorite missions. It's going to launch next year. The principal investigator is a woman, Lindy Elkins Tanton, and she is just remarkable. And Psyche is a metal asteroid. They think that Psyche was the core of a planetesimal, an early planet that somehow got exposed. This is what we think Psyche looks like. We know that it has two massive craters. We know that it's mostly iron nickel. We have no idea. And it's just a really exciting mission. Psyche is about 200 miles across. Actually, it's about 200 kilometers across, about 120 miles, and it is one of the larger asteroids, and it's very unique. And that really is, oh, my advice for high school students. I did think about some, it's been a long time since I've been in high school. One thing I know is whether you want to work in a museum or as a teacher, a four-year college degree is important. I know a lot of people lately have been thinking about trade schools, but for my job, they require a four-year college degree, any major job in the museum. And I know for teachers, doesn't matter what the degree is in, though. I mean, there's people that have specialized in communications, or we have one interpreter that majored in theater. Just a four-year college degree. Do what you love. That's important. I love my work. I speak to people outside of my work because I just love astronomy so much. NASA needs lots of skilled people. Scientists are one way to go, but NASA also needs PR people, coders, needs artists, all sorts of people. It needs cooks. It needs sewers, seamstresses. If you have a skill, no matter what the skill is, you can do it for NASA. They need everyone. There are lots of opportunities if you want to get involved with NASA. Some of them are internships. I just put down in the bottom. Lucy is got online interactive classes for undergraduates, and some are internships. All the missions really do. Psyche is also very good. They are headquartered at Arizona State. And so if you became an Arizona State university person, you probably could get involved with one of those. I'm none of those things, but the Solar System Ambassadors Program keeps me sharp. And there's also a Museum Alliance. NASA has stuff for park rangers and all sorts of opportunities that you can take advantage of, even as a college student. Now that I've talked pretty much all my time, it's time for questions if we have any. Just type them in the chat or raise your hand and I'll try.
All right, we have some questions in the chat from Ujwal. He says, is it possible to examine or detect certain possible signs of life on board the rover?
Is it possible to detect certain signs of life? Well, it's all going to be fossilized. Did you say Voyager rover? No, Perseverance rover.
Yeah.
They really need to bring them back to Earth to be sure. They're going to look for organic molecules. You saw what a stromatolite looks like. It's certainly a kind of a unique layered, the lumpy shape, but there's no way to know for sure without bringing the samples back.
All right, Shristi has a question. I'm going to let her unmute.
So I was wondering if you think it would be more efficient or even possible to, so you said that we don't know if we'll be able to fly a rocket back from Mars to Earth, because we don't know if we can create oxygen on Mars. But do you think it would be possible if we were that instead of bringing the samples back to Earth, we could bring them to the ISS?
Hmm. They need a lot of equipment, and I'm not sure exactly what equipment they would use, but it sounds like some of it is kind of heavy. So they just want to bring it back to Earth. Now, remember, the ISS is just a little bit above Earth, maybe 250 miles or so. So if they can bring the samples back to the ISS, they certainly should be able to get them back to Earth. And they also want people worldwide to be able to study them, not just the 6 or so people that live on the ISS. So it's an idea, especially because there's only microgravity on the ISS if they wanted to do something by that. But I think that they are planning to bring them back to Earth. Thanks for your question.
Awesome. Next, I think Ujjwal has a question. I'll let him unmute.
Isn't Ingenuity completely solar power based?
Ingenuity is solar power based. Now, Perseverance has plutonium that it's using, but Ingenuity is solar power based. It's only going to have, they think, 5 flights if successful, so it doesn't need a lot.
Sorry, my internet cut out. Did you answer his question? Okay. I think Priya has a question next.
Okay.
Sorry, I couldn't hear that. Okay, go ahead.
Well, so I just wanted to know, you said Psyche is going to this asteroid that once was a planet. Do you think it aimed to like bring back some of the minerals from that asteroid, or is it more of just going there to take pictures and observe? And like, do you think something like asteroid mining would be an idea for the future?
That's a great question. Yeah, Psyche is not going to bring samples back. They're just looking at Psyche as possibly a bare core, but they don't know yet. And they don't, they can see that it has a lot of nickel and iron, but they don't even know if it's bare on the surface, or it's just mostly nickel and iron. It's kind of interesting because we can't really look at a planetary core. Asteroid mining is something that we are studying. I have an activity for small kids about drawing what they think asteroid mining would be like. But I don't know. Psyche is kind of far as asteroids go. I don't think people have really put the two together. Maybe it's a chunk. What they're more interested in is whether Psyche, the material has melted or not. If it's differentiated, which means that it was once a core of a larger body, or if it's just a metal asteroid in space.
Got it. Thank you.
All right, if anyone has more questions, you can raise your hand or put it in the chat. And
I gotta stop share. That makes sense.
Looks like Ujjwal and Trishti have more.
All right, let me let Ananya ask your question and then they can go.
Thank you, Sophia. So I had a question. Does mining on Mars seem like a financially feasible option at this point in time?
I don't know what they would look for if they were mining on Mars. The metal makes sense. Mars, it's got a lot of rock. So I'm sure there are people that are interested in it. I just don't know what it would get us. I mean, there are some people talking about mining on the moon for water. If there's water on the lunar South Pole, for instance, which sounds kind of interesting, because water, of course, has oxygen, which also people say, fuel and breathing. So it's possible if there's something that can be gained by it, I'm sure people will be looking towards it. And lawyers would be involved, because who owns the moon? Who owns Mars? Who owns asteroids? Is it first come, first grab? So if you want to become a lawyer, NASA needs lawyers too.
That's funny. Okay, next, I think Anamita has a question. I'm gonna let you unmute.
Thanks. So I have a question about the rover itself. So since it takes a few minutes for the information about the rover to transmit back to Earth, would we know for sure when the rover actually landed on Mars? Like by the time the scientists on Earth found out that the rover was on Mars, is that real time or do we find out delayed?
It was delayed. We found out delayed, and so it actually landed 10 minutes before or whatever. So that's something they have to really look at, to make sure that everybody's clocks are in sync. There's some things on Mars, like sunrise or something, that we have to figure out on Mars time. I know that a lot of the Mars scientists from previous missions actually sync with a Mars day, a sol, which is 24 hours and 37 minutes. So they briefly work second shift or third shift or whatever. But yeah, all the time that we see is delayed, and the rover really has to think on its own.
Thank you.
You're welcome.
All right, next, I think Ujjwal has a question.
How are scientists so sure that Mars contains life that is similar to primordial Earth life? And is it possible to have unrecognizable life that existed on Mars?
There is, so the last one is, unrecognizable life. Life as we know it. All life on Earth needs water and energy, and there might be stuff that's, I watched an old Star Trek episode where life was silicon based. You never know. That's all we can do is to identify it. And from the graphic that I showed you, they think that Mars was habitable long ago, and that if life formed on Earth, similar life might have formed on Mars. That's just a guess. They are not sure. We teach a lot of homeschoolers in South Carolina, and they're not really fond of the thought of extraterrestrial life. So I think a lot of people just don't want to go there. It's just a thought. But what I learned in my training long ago was that if something could exist, it probably does somewhere. So maybe if life doesn't exist on Mars, that's okay. That is a discovery. If we don't find life on Mars, that's okay. It means that life is rarer than some people think. That's just as valid. You shouldn't be one way or the other about science. You have to follow the facts. I hope that helps.
Thank you. Next, I think Shirstina's question.
I just wanted to say that it was so funny to hear about the asteroid mining conversation, because I was reading an SAT passage the other day which talked about that. But my question is that how did scientists come across Psyche 16 if it's so far from the Earth?
It's going to do a gravity assist by going near Mars. It's you know, it's not as far as Jupiter or Saturn. You know, the main asteroid belt is between Mars and Jupiter, and it's a main belt asteroid. So, but it will gravity assist by going across Mars's path, and we've gone plenty further before. It's just going to take a few years.
Okay, for some reason, I thought it was farther than like Jupiter and stuff. That
No,
makes sense.
it's not. It's a main belt asteroid.
Okay.
All right, next up, Aisha has a question.
All right, so this may sound kind of sci-fi, but when humans get to Mars, will we ever be able to live outside of biospheres? And can we like actually cultivate crops on the Martian soil?
I don't know either of those answers. I know that the movie The Martians is not based on reality, even though I haven't seen it. That that there's not a strong wind because there's only 1/100th of the atmosphere. It's really, really cold there. So I don't know what kind of biosphere or tent they're going to need or what they're going to be able to breathe. I hate to think of us terraforming the whole planet, though, especially if there was once life there. And I just don't know. That's all I can say.
Thanks. Anumita has a question next.
So if the rover, if Perseverance had landed like away from Jezero crater where it's supposed to go, would that be the end of the mission, or would Perseverance find its way back to Jezero crater from wherever it landed? If there was a difficulty in the entry, descent, landing process?
It really depends. There are cliffs that it could not climb. It's got the Ingenuity helicopter because there are places that Perseverance cannot go. So if it went nearby, hopefully it would be okay to drive. It's going to drive around more than the other missions because it's got to collect samples in a lot of places. The wheels, it's going to go 3 times faster than the fastest record on Mars, which isn't all that much. But it was kind of designed to go over little rocks and things, but I guess it depends where it ended up.
All right, thank you. If anyone has any more questions, you can raise your hand or put them in the chat. Earlier, Ujjwal asked, can you work part-time for NASA?
I'm sorry, I didn't hear that.
He asked, can you work part-time for NASA?
Do I work part? No, I'm a volunteer. I am not associated with NASA except as a volunteer. NASA JPL, they give me a little badge, and they make sure that I know that I don't represent NASA in any way, shape, or form. They do give me liability insurance. I don't know if I would fall over on the computer or not, but that's really my extent. And our museum in South Carolina is trying to borrow a moon rock. You may have seen that Joe Biden's got a moon rock in the Oval Office now. We're trying to get one of those, and I have to go to Houston and Johnson Space Center to collect it. It has to be hand delivered. So that's the closest I'm going to be.
Okay, thank you. Ishan in the chat asked, how long would a human trip to Mars take?
Now, it would be about the same as Perseverance. It launched on July 30th, and it just arrived. So about 8-9 months, but that's assuming that we're all lined up. Mars and Earth come close to each other every 2 years or so. So it's 8-9 months, but excuse me, it takes about 2 years for the next possible flight. So if you want a round trip, it's going to be, 2-3 years or even 4.
Thank you. Sujal, I'm going to unmute you. I think you had a question, right? Where'd he go? Okay.
All right, cool. So my question was that I looked it up on the side that Curiosity has only traveled 14 miles, right? And that's a pretty short distance, especially like when you're considering it's a whole planet that the rover has to like try to explore. So my question was that have there been any significant improvements, like other than just the design of the wheels, that enables Perseverance to travel farther in Curiosity?
No, but the wheels should provide it to go 3 times faster, and it's got more has cams, so it will be able to look at hazardous obstacles and process that, and it's got the helicopter, so the helicopter is gonna look in places where it can't go, but it's pretty much because it's got to collect 40 some odd samples, so it's gonna have to speed up. But yes, you can see that the existing rovers haven't traveled all that far.
Thank you. I wanted to correct one of the earlier questions. He actually said, can you work part-time for NASA? So if you don't want
I thought you said, do you?
No, I messed up.
Yeah, NASA hires a lot of contractors. It's difficult to work directly for NASA anyway. I had a coworker once who worked for one of the companies doing PR for NASA. So you certainly can work contract work or part-time work for NASA. There are a lot of internships and summer internships and things like that for young people, because they recognize that high schoolers, college students are our future. And definitely look into that. And remember, you can be a scientist, but you don't have to be. They need lots of people with lots of skills. Just do what you love. That's my recommendation.
Thank you. In the chat, Ishan asked, is the Perseverance on the move 24/7 or does it take breaks?
It does take breaks. They have to, even though it's pretty autonomous, they have to upload and download information to it. So when they do that, it pretty much has to take a break. I'm not sure. That's a good question. I'm not sure how long the breaks are, or whether it's just operating during the day or during the Martian day or anything like that. I do not know. That's such a great question.
Cool, we'll have to look into that. Shristi, I'm gonna unmute you next. Okay, there we go.
So I searched it up on the side and it said that the Perseverance rover uses a thermoelectric generator to power it, but I didn't really understand that. So I was wondering if you could go a little bit more into depth about that.
I know that it uses plutonium, and I don't know more than that. It's got a special name to power, our mast or whatever. There's an acronym on what the power is. So you should be able to look that up. I wish I knew more, but I don't.
Okay, that's okay.
Great, next, Alex had a question.
So considering like how lightweight Ingenuity is, like you said, around 4 pounds, does JPL have any like specific countermeasures to like say protected during a Martian dust storm?
No, they don't. Apparently, Martian dust storms, which you think sweep the whole planet, are a lot less than you would think, than movies make you think. Remember, it's 1/100th of Earth's atmosphere. So a strong wind would barely touch your hair. It really isn't that significant or powerful. They're going to do, they believe, 5 test flights very quickly into the mission. So it won't have time to fall over. What, even if it does, they say proof of concept. If they get any useful pictures, it's going to stay within a mile of Perseverance, and load pictures only to Perseverance. So if they get usable pictures of anything that Perseverance normally doesn't see, that's gravy.
Thank you.
Ayush has a question. Sorry, go ahead.
Okay. So a more reality-based question. So was Perseverance actually like built to last? And I think Elon Musk is planning a Mars mission, so he's making great progress. So will the first people on Mars ever make contact with Perseverance?
I'm sorry, did you say it again?
Was Perseverance really like built to last? And will the first people on Mars ever make contact with it?
Well, they always have the primary mission. For Perseverance, it's 1 Martian year, which is about 2 Earth years. So that's how long it lasts. Now, Curiosity is still going strong, and it landed in 2012. So you don't know. I mean, Spirit and Opportunity now have gone, and I don't know. Elon Musk is so visionary. I really don't like the satellites that he's put in orbit, or the Roadster. I don't really understand its significance, but he is really visionary with a lot of the stuff he does. So I wouldn't put it past him to have people visiting Perseverance one day.
Okay, thank you. That sounds interesting.
Cool. Kaylee has a question in the chat too. She said, if something happened to Perseverance that caused it to break down, what would NASA do?
Well, there's nothing they really can do. Now, InSight had a mole, which was a drill, and that died, and they just kept trying again and again and again until it started to work, or rocked it or stuff like that. But it's so far away, it's pretty much on its own. So if it died, only 1 out of every 2 or 3 missions to Mars is totally successful. We just chalk it up to landing on Mars is hard. Have you heard that? That's what they keep saying. Mars is difficult. So, just one of those things. And we'll try better next time. Learn from those mistakes. They learned from the Curiosity's wheel structure, and they built it better next time.
Awesome. Shristi, go ahead.
So for Perseverance, so I know how everyone keeps on saying that it's completely on its own, but I thought that the JPL control group was actually leading the rover, or is that wrong?
Well, they certainly watch it. I know that they, when Spirit and Opportunity landed on Mars, they watched them 24/7, just in case a Martian cow came walking by. They just didn't know. So they certainly will watch them, but remember, with the 10-minute lag, by the time something happens and they hear about it, it's probably too late. It's gone off the cliff or whatever it needs to, or whatever it has. So they do watch it, and they can send commands if it figures out that there's something really bad. It will stop and wait for new signals, and someone does, like I said, watch it.
Okay, so is it like pre-coded in terms of what it needs to do?
It is. It's got computers, and it is pre-coded. They send it new information. I'm not sure how often, but every few days probably. And they get the pictures from it. I mean, those pictures aren't beamed back instantaneously. They get the information, and if it needs to be pre-coded, they will do that. They've done that with all their missions, even the Voyager missions, which are outside the solar system now. They issue those new commands. They use the Deep Space Network for that. I don't know if you know about the Deep Space Network. Those are 3 dishes. One's in California, one's in Spain, and one's in Australia. And the idea is that one of them is always facing any object. So one of them will be looking at Mars. So if Perseverance does send something back and need instructions, there's a NASA instrument prepared.
Okay, that's really interesting. Thank you.
There's a movie called The Dish. No, that might not be it. But anyway, it's really, I think, cool about the 3 deep space networks. And you can see, there's a website where you can see all the signals going back and forth to the various missions, because all of those times have to be allotted.
All right, thank you. We have time for, I think, one last question. Okay, in the chat, Spandan says, is there a plan for NASA to send humanoid robots who can be based in Mars, do the research, experiment, and send the results back to NASA rather than NASA only getting images from Perseverance and doing analysis?
Humanoid robots, not that I know of. They hope to send people to Mars someday, and they're working really hard to get astronauts onto the moon again. So yeah, no.
All right, I know I said that was the last question, but one from Ujwal in the chat from a few minutes ago. How large of an area will the rover sweep?
It's a good question, and I could guess, but I'm gonna say I don't know, because I don't want to give you something that's wrong. So it's okay to say you don't know, I guess.
Thank you for answering all our questions. That was really informative.
All right. So with that being 3:56, we would like to wrap up our Q&A session. Thank you all for joining, and we hope you enjoyed the really informative presentation that Ms. Holmberg gave us. A lot of great information, and we're really hopeful for the future as to what NASA holds.